Welcome to Math with Mrs. Seeley. Let's get started with this 2019 free response question number 5. We are given a shaded region that is bound by two curves, the y-axis and the vertical line, x equals 2. We are asked to find the area of that shaded region. Recall that when you're trying to find the area between two curves and the picture is like this, it's going to be the top curve minus the bottom curve. So what we need to do is we need to go back up here and decide who's the top and who's the bottom. With this right here, my first instinct is to see this and think parabola. Looking at your two pictures, he's the one that looks like a parabola. So that's my h of x, or top curve. Then by default, this cosine curve would be the bottom curve. So if we're asked to find the area between two curves, we're going to integrate from 0 to 2. The top curve, which we now know, is h of x, minus the bottom curve, which is g of x, and it is dx. If you knew to integrate the area of the top curve minus the bottom curve from 0 to 2, and you put your 2x there, give yourself your first point. Now, we are asked to actually find this area. And you guys know that question 5 is without a calculator, so we're fixing to have to grind this one out. So I went ahead and put my h of x curve in right here where h of x is, and my g of x curve here. Now I want you to think that this is 4 terms: term 1, term 2, term 3, and term 4. And we're going to integrate each one of those individual pieces. All right, so to integrate the first one, to integrate 6, that's pretty simple. That's just going to be 6x. Now, to integrate this next term, we're going to need a u substitution. So u is going to be x minus 1, and then du, which is just the derivative of that, which is just x, would be 1 dx. So as I integrate this, I'm going to have my negative 2. Where that is, I'm going to have my u to the second power. And then dx is du. Recall to integrate, and this is an easy one, you're going to add 1 to it and make that u to the third, and then you're going to divide by it. So you have negative 2/3 u to the third. I don't want to change my limits of integration, so therefore I'm going to go put my u back in and have 2/3. But where the u is, I'm going to put in x minus 1 to the third power. So we've got that integrated. Now minus, to integrate negative 2, that's pretty simple. That's going to be negative 2x. To integrate this, we're going to need another u substitution. So u is equal to pi over 2x. Then du is just the derivative of that, which is pi over 2 dx. All right, let's go substitute it back in so that I can integrate it. You have a 3, a cosine, put your u in, and then we have dx. Well, dx is equal to 2 over pi du. So 2 over pi du. So we're going to think of this right here as, I'm going to go ahead and make that be 3 times 2 and have 6 over pi. The integral of cosine is sine u. I don't, again, want to change my limits of integration, so I'm going to go ahead and put my u back in. So I have 6 over pi, the sine of u, which is pi over 2x. Okay, so I've got my 4 terms integrated. All right, now we need to go through and we need to put in our 0 and our 2. I think what I'm going to do is separate these because this is pretty crazy. All right, so I'm going to put a 2 in first through this, and I will put in the 0, and then I'll do the same thing to this side. So let's put a 2 in first. So 6 times 2 is 12, minus, put a 2 right there. 2 minus 1 is 1, and cube it is 1, and then times 2/3. So that's me putting a 2 in. Now minus, let's put our 0 in. 6 times 0 is 0. Then put your 0 here. 0 minus 1 is -1, but then I'm going to cube it, and that's still going to be -1. And -1 times -2/3 is going to be 2/3. So this was me putting the 2 in and then putting the 0 in. Minus, let's do the same thing over here. I'm going to put my 2 in. So -2 times 2 is -4, plus, let's put a 2 right here. If I do that, because this is a little more complicated, I'll write it out for you. The sine of pi over 2, but we're putting that 2 in. Those give me 0, or they cancel out, and I have the sine of pi. Okay, recall that if you want the sine of pi, that's over here, and sine is the y-coordinate. So you actually do get 0 right there. And then plus, now let's put the 0 in, and that's going to be 0 plus 6 over pi, the sine. Put a 0 right there, and you have the sine of 0. Well, the sine of 0 is also going to be 0 right there. So that's me putting my 2 in, my 0 in, my 2 in, my 0 in. So I'm going to have 12 minus 2/3 minus 2/3. That turns into a plus 4, and then that's just all zeros. So then I have 12 minus 2/3 minus 2/3 plus 4. So my mind is saying 12 plus 4, which is 16, minus 2/3 minus 2/3. So that's, again, we have no calculator. 2/3 and 2/3 is minus 4/3. So my mind is thinking that's 1 1/3. So 16 minus 1 1/3 is going to be 14 2/3, or if you want that as an improper fraction, 44/3. If you were able to get through this problem, let's take a look and see where they gave you your points. All right, if you integrated your cosine right here, if you were able to integrate that and get your sine, give yourself a point for that. All these other integrals, the 6 to the 6x, this to this, and your -2 to your -2x, you get another point for all those others. Then all of this calculation to get to these answers here, you get your next point. And that was a lot of work. So pat yourself on the back if you got through that. All right, B part says region R is the base of a solid. For the solid, at each x, the cross-section perpendicular has area of that right there. Find the volume. Okay, recall that to get volume, you integrate area. So if I integrate area, I get volume. So then to find the volume, I'm going to integrate this area right here. And again, we're going from 0 to 2. It's the same picture up here. So from 0 to 2. So I'm going to integrate that, and I'm going to have 0 to 2 right here. So 0 to 2 dx. If I integrate this, I'm going to have to do a u sub again. So we're going to let u equal x plus 3, so that du is just dx. So that this becomes the integral from 0 to 2 of 1 over u, and then dx is just du. If you integrate that, that's going to be the natural log of u. But again, I don't want to change my limits of integration, so I'm going to go back and put my u in. So I'm going to have the natural log of x plus 3 from 0 to 2. So let's put those values in. So put your 2 in, and you have the natural log of 2 plus 3, which is 5, minus the natural log of 0 plus 3, which is going to be 3. But they're going to want you to, they would give you that, but you could also know that if your logarithms are apart by subtraction, you can bring them back together by division and have the natural log of 5/3. But they would give you your answer right there too. Okay. Plus, you also get a point for knowing to set this up and integrate from 0 to 2 of the integral, or their area is 1 over x plus 3. Okay, the last one, write but do not evaluate an integral expression that gives the volume of the solid generated when it's rotated about the horizontal line y equals 6. Okay, now we're also finding volume, but we're rotating. So let's go back up here and think about the line y is equal to 6. So that would be up here, right here, and we're going to rotate this. So you've got an outer curve and an inner curve. It's a little one, but this is going to be a washer method. And so when we're going to integrate this, we're going to have the washer method. Because we're integrating about a horizontal line that acts like dx, so we're going to say pi, and we're going to go from 0 to 2. Now, because it's a washer, remember that you say outer radius squared minus your inner radius squared. Right there, because these are circles, it's pi r squared minus pi r squared. All right, now the next thing is this. When you're going about a line, your radius is now the distance between the curve and the line. This distance right here between the curve and the line, or the curve and the line. So your radius, when you're going about some type of a line, you can either say line minus curve or curve minus line. It's completely up to you which one you do. So I'm just going to do maybe the line minus the curve. So the line is 6 minus the curve. All right, let's go back and think which one's on the outside. So let's come back up here and look. The outside is this g of x. He's the one that's the outer. So g of x. The inner one is right here, or h. So it's going to be line minus curve. So line minus the curve, which we just said the outer one is g of x. Go back up there if you need to and look at your picture. Squared, so this is your outer radius, line minus curve squared, minus your inner radius, which is line minus, we said the inner curve is h of x, squared, and then put a huge dx right there. Okay, let's get some points for this. All right, on this one right here, if you get the pi and the 2 and the 0, so if you get your limits and this constant, you get a point. Even if you don't get this right, you're still going to get your point from there. All right, then you're going to get another point for the integrand. That's you saying that you know it's line minus curve squared minus line minus curve squared. They give you a point for that. And then they also give you another point for the form of the integrand. So that's going to be your dx, your kind of parentheses, and so you get those points for that. Well, I hope that this has been helpful to you in preparing for your AP exam. This was a solid question this time, for real. But if you did find that helpful, please like, comment, and subscribe to the channel. And be sure to check out other AP Calculus free response question explanations, as well as other tutorial videos on the channel. See you next time.